Alright guys, this is Chapter 3, Test A, and this is a way for you to get back some of your points. You might not have gotten every single question incorrectly, but I'm going to go over every single question on this test. There are actually 17 points worth of problems. So I'm going to start with number 1, 3 divided by 5 6. And basically what this problem is saying or asking is if I have 3 wholes and they're divided into pieces of 6, how many groups of 5 am I going to have? So I can do it mathematically, and what I'm going to do is I'm going to make this denominator the same as this in order to divide. So I would multiply this by 6 and multiply this by 6. And that leaves me with my new equation, 18 over 6 divided by 5 over 6. And all I do is divide the tops because my denominators are the same. And I'm going to show you why with the picture in just a minute. I only pay attention to the top. 18 divided by 5 looks like this, 18 over 5. And then I have to top dog in the house to solve my problem. 5 goes into 18 3 times. 5 times 3 is 15. I have 3 left over. My answer is 3 wholes and 3 over 5. This becomes my numerator. This is my denominator. I'm going to show you exactly why this is our answer and why we don't pay any attention to these bottom numbers. Here's what it looks like if I draw a picture. I'm going to take 3 wholes and I'm going to use some colors to help us here for you to see it. I'm going to divide it up into pieces of 6. So here's my whole number, 3 wholes. This denominator tells me how to slice my pieces. So each whole now has 6 pieces. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's 18 little pieces. Here's our 18. Okay. This numerator here tells us we're going to make groups of 5. So here's 1. Okay. Here's 2. Here's 3. I have 3 groups of 5. That's our whole number here. This is our whole answer. What I have left is a piece here, a piece here, and a piece here. 3 pieces out of the 5 I'm supposed to be grouping. I have 3 out of the 5, and that's where this number comes in. 3 groups, 1, 2, 3, and 3 out of the 5 pieces. 3 3/5. So you can see it in picture form and in mathematical form. These denominators don't mean anything to us once they're the same, because what it does is tells us to cut these all into the same pieces. For number 2, I don't have a whole. I only have a quarter. So I'm only using 1/4. None of these matter. Okay. I mean, they matter because they're there, but we're not going to look at them. This tells me I'm making 1 group of 8. I have to cut this 1 piece into 8s because that's what the denominator tells me to do. Pieces of 8. Wait a minute, that's not right. Just a minute. I gotta think here. I'm only concentrating on the one piece. This piece is 1/4. Okay, here's where I went wrong. They want me to make pieces of 8. So I divide each of these into 2. So now I have a total of 8 pieces, even though I'm not using these 3. I'm concentrating only on these 1/4. So here I had 1/4, 2/4, 3/4, 4/4. Then I cut those into pieces of 8 because that's what it told me to do here. So I have 8 pieces, but I'm only focusing now on this 1/4 piece. How many of those pieces of 8 are in the 1/4? So how many pieces do I have here? 1, 2. Let's look at that mathematically. 1/4 divided by 1/8. Make my denominators the same. I multiply this by 2. I multiply this by 2. That gives us 2/8 divided by 1/8. Ignore the bottom. It gives me 2 divided by 1, which is the same as 2. And that's why our answer works. We just proved it. I'm sorry I started us off a little bit on a crazy path. I forgot that we were supposed to divide the whole thing into 8 pieces, but only concentrate on the 1/4. Okay, number 3 gets a little bit more complicated because we have a mixed number. So before I divide anything, I'm going to take that mixed number and turn it into an improper fraction. I have to do that first, and I know this is not focusing. Okay, so 1 1/3, 1 whole is 3/3, plus 1/3 gives us 4/3, divided by 2/5. I can divide once I make my denominators the same. I'm not going to draw a picture for this one because it's too many little boxes. I proved why it works here and why it works here. Why I can ignore my denominators once I've made them the same. So I'm going to make them the same. I'm going to do 3 by 5 and 5 by 3. And that turns my problem into 6/15 divided by 20/15. Denominators are now the same, and I divide straight across. 6 divided by 20 gives me 6/20. Remember, 6 divided by 20, that means the same thing here. 6 divided by 20. All I have to do now is simplify. Divide this by 2, divide this by 2. 6 divided by 2 is 3. 20 divided by 2 is 10. There's nothing else that goes into 3 and 10 equally. So 3/10 is my answer. For the next one, I also have mixed numbers. So the first thing I have to do is turn them both into improper fractions. 1 1/2. So 1 whole here would be 2/2 plus 1/2. So that's 3/2. Divided by, so 2 wholes with denominators of 5 would be 10/5 plus 3 is 13/5. And my denominators are not the same, so I have to make them the same. The least common multiple of 2 and 5 is 10, So I'm going to multiply them by each other and rewrite my numbers, or rewrite my equation. 15 over 10 divided by 26 over 10 is my new problem. Now that my denominators are the same, I divide straight across, which is 15 over 26. Can 15 over 26 be simplified? It's not divisible by 5, and it's not divisible by 3, and it's not divisible by 2, so there's nothing else that goes into it. That's my answer. All right, that takes care of our division. Now we're going to talk about some multiplication. And this says 5/10 times 9. So I'm going to rewrite it. And I'm just going to multiply regularly. 5 times 9 is 45. And then, because I go in one decimal place here, I go in one decimal place here. And my answer is 4.5. I don't have to do the 9 times 0, but I can. It would look like this. And my answer is still the same because I still only go in one decimal place. I'm trying to make it focus. Okay. I'll do it over here. 0.042 times 7. I can kind of ignore these zeros. They're important, but when I'm multiplying, I don't need them right away. So 7 times 2 is 14, carry the 1. 7 times 4 is 28, plus 1 is 29. 7 times 0 is 0, plus 2 is 2. And I can continue. 7 times 0 is 0. Okay. Now what I need to do is count my decimal places. 1, 2, 3. 1, 2, 3. So my number is 0.294. There's my answer. Okay, 2.3 times 0.7. With a number like this, or with two numbers like this, I don't have to line up my decimals. I just have to line up my digits. So I'm not going to even worry about the decimals until the end. Just as long as I have a decimal place, or a place value. Okay, as long as my numbers are there. For over here, 3.62, I'm just going to line up my numbers and worry about the decimals later. Okay, so there's an 8 under the 2 and a 4 under the 6. Count the decimals later. Okay, back to number 7. 7 times 3 is 21. Carry the 2. 7 times 2 is 14. Plus 2 is 16. Placeholder. 0 times 3 is 0. 0 times 2 is 0. 161. Now I have to count my decimal places. 1 here, 1 here, for a total of 2 places. I go in 1, 2. 1.61 is my answer. Let's look at number 8. Remember, I'll deal with decimal places later. 8 times 2, 16, carry the 1. 8 times 6, 48, plus 1, 49. 8 times 3, 24, plus 4, 28. Placeholder. 4 times 2, 8. 4 times 6, 24, carry the 2. 4 times 3, 12, plus 2, 14. Add them up. Now, here's my number. I have to think about my decimal places. 2 here, 1 here, 3 places in, start at the end, 1, 2, 3. My answer is 17 and 376 thousandths. For 9 and 10, to make dividing easier, I'm going to multiply them by a power of 10. So I'm going to do, if I multiply them by 10, it moves my decimal place over 1. If I multiply them by 100, it moves my decimal place over twice. These both only need to move over once. So if I do times 10 times 10, it turns it into 45 divided by 5. Which is easy. I just now have to do top dog in the house. Top dog always means either the top number or the number that comes first. 5 into 45 is 9. That's my answer. This one is a little more difficult because I have one that is in the hundredths place and one that is in the tenths place. But I have to multiply them both by the same power of 10. So I'm going to do it by moving this decimal over twice, which is 100. That means 1, 2, 62. And that means 1, 2. And I have to have that placeholder 0. My numbers become 62 divided by 80. Top dog in the house, meaning the first number goes on the inside. Right away, I know my answer is going to be a decimal because I know 80 does not go into 62. 62 is too small. I can't make 80 if I only have 62. So I'm going to say 80 does not go into 62. I have to put a decimal and a 0. Now that I have this decimal, I can add zeros to all my remainders. Now I can do 80 into 620. I think about 8 into 62, which is going to be similar to 80 into 620. 8 into 62 goes 7 times. 7 times 8 is 560, or 7 times 80. Now I have a remainder of 60. Because I already have a decimal place up here, I just add a 0 to my remainder. And again, I think of 8 into 60, which is going to be the same thing. 7. 56, or 560. My remainder is 40. Since I already have a decimal here, I add a 0. 80 into 400 is like saying 8 into 40, which I know is 5. 5 times 80 is 400. There's nothing left. My answer is 775 thousandths. All right, going to the back, the word problems. If 30 gallons of water are poured into 1/5 gallon containers, how many full containers can be filled? So what this question is asking me is that I'm taking 30 gallons, and I'm putting it into a number of 1/5 containers. How many 1/5 containers is it going to take me? So I'm taking the 30, I'm dividing it up into 1/5 gallon containers. And I don't know what this is. I could keep going on. That's why I'm going to figure out. This is just what my mental picture looks like in my head when I think about it. I have these containers, and I'm putting into smaller ones. Okay? Here's my mathematical equation. Knowing what I know about dividing fractions, I'm going to put a 1 here. And I can't divide unless my denominators are the same, just like we did on the front. So I'm going to multiply 1 by 5 and 30 by 5 and rewrite my equation. This can stay the same. $30 times 5. 5 times 3 is 15 plus the 0. 30 times 5 is 150. Now that my denominators are the same, I divide straight across. 150 over 1 is the same as 150 containers. So if I were to keep drawing this little picture that I do that in my head, I'd have to draw 150 little arrows going off, because those gallons are being divided up into smaller pieces of 1/5. Number 12. Peter buys 8 5/10 square feet of carpet. The carpet costs $10.20 per square foot. How much does Peter pay for the carpet? So I am multiplying the amount of money that it takes per square times how many he bought. And I'm lining up my numbers, not my decimals. Remember, I'm going to take care of those decimals at the end. Line up my numbers. 5 times 0, 0. 5 times 2, 10. Carry the 1. 5 times 0 plus 1, 1. 5 times 1, 5. Placeholder. 8 times 0, 0. 8 times 2, 16. Carry the 1. 8 times 0 plus 1, 1. 8 times 1, 8. Add them all together. 0, 0, 7, 6, 8. Now that I have a big long number, now I look for my decimal places. 2 here, 1 here, 3 places in, 1, 2, 3. And because it's asking me for money, I want to make sure that I go 2 places after the decimal. So my number is $86.70. It's money. Don't forget, because it's money, you want hundredths place. All right, finally, our last one. Number 13. This one is tricky because there are a couple different steps. Sandy has 6 sheets of colored paper. She uses 4 sheets to make posters. So Sandy has 6, she uses 4. How many does she have left? Sandy now has 2 sheets left. Let's continue to read the problem. She cuts the remaining paper, which is 2 sheets, into equal rectangles to make greeting cards. Each rectangle is 1/4 of a sheet of colored paper. How many greeting cards does Sandy make? Here's my picture. Sandy has 2 sheets of paper. 1 sheet, 2 sheet. Each is 1/4. So she's taking 2 and dividing it into 1/4 pieces. How many pieces will she have? Well, here's the mathematical way. Here's the picture way. 2 over 1 divided by 1 over 4. Make my denominators the same. Multiply or divide straight across. She should have 8 cards. Here's my picture. Here was 1 sheet of paper, 2 sheets of paper, cutting it into 4s. 4 pieces, 1, 2, 3, 4, 1, 2, 3, 4. Each greeting card is just 1/4. So 1, 2, 3, 4, 5, 6, 7, 8. She makes 8 cards. I hope this helped you understand a little bit better. I know I kind of went a little quickly, so I encourage you that if you did not stop and pause while I was going through this, to go back and look at the ones that you didn't understand. Turn this back into me with your original test, and I will give you more points on top of what you had already to kind of bump up your score a little bit more. All right, thanks.